Alright, I just finished mounting my circuit for this morning. This NOT gate built out of one single transistor, a switch, 10K resistor, and one LED. So before I explain a bit how this works, let me tell you how my breadboard works. So actually the breadboard is divided into two. As you can see, this whole part is connected, especially the powers. I'm actually talking of the powers. So this side of the power is connected up to here, so these lines are connected like this, but it doesn't go through this side. So to fix that problem, I had to connect these two areas of the breadboard, so making this whole line complete and the other one to complete. So the same thing. So this is how I connected the two sides of the power. So the outer lines, I've taken them as positive sides, because this breadboard is not marked with colors. So which is this red line actually is the positive bond I'm using, and the inner lines I've used them as the negative side. So from now you can understand, any line, anything you see connected to the down line here, the inner line here or here is connected to the ground, and anything connected to the outer line is connected to the high. So how is this working? This transistor actually, the middle pin is the base. So I hope you can see it from this side. Okay. So the middle pin out actually here is the base. The right pin, which this side here, is the collector, and then the left one connected to the ground, and then the green wire here is the emitter. So I've connected this resistor, 10K resistor, to the high as a pull-up resistor, and in between there I have the output. So the output is connected to the ground. So to show that something is going on, I've collected an LED, and the LED goes to the ground. It's normal, because I think if you look at it here, it's kind of closed circuit here, from the positive through the resistor, through this wire to the LED, through the negative. So this can be seen as a very simple circuit, a torchlight circuit, except that here we made it look complicated. So it's obvious that if there's any current going through, this will go on, because there's nothing preventing the current from going from the positive through the resistor to the LED to the ground. So let's see what happens when we connect it. So for the power, I have some wires here I've made. So this one with the white lines is positive, and the one with fully black is negative. So anywhere I put them, it should work. So if I put this one here, since it is the negative, so it should go inside here somewhere here, because I just said I'm going to consider the inner lines as the negative. So I will take this one to the outer, which is this. So as I said, at the moment I connect it, this circuit actually works. So let me take it this way. My power is not stable, so it's kind of, whenever I put it in, connect it to the power, this circuit starts to have power and through it, and then the LED goes on. So you can see that's why there's no need actually to put any resistor here trying to protect the LED around here, because it's already a closed circuit, and this resistor protects the LED already. So I have a switch here connected to it. So what does the switch do? So let me try turning it this way so that we can see. So I've connected the switch to the base of my transistor in a way that I can This resistor, how the way it works is this: when I connect this side to it, goes through, the current goes directly like this, even if you don't press the button, whenever you don't press the button. But when you press the button, it goes from the base. The base is usually from the beginning of the switch, so this is where you press, the handle is here, and this is where the handle is fixed. So this is the base. So if you don't press the button, the current goes through the whole switch, so it goes from the beginning to the end. But whenever you press, it goes from the beginning to the middle to this side. So what I did is, because I want to be able to alternate the base of the transistor between the high, which is the positive one, is the positive line, and then the negative line, the ground. So I've connected these two sides because I can switch between the base, the middle, and then the end. So I've connected the middle, which requires me to press the button, to the high, and then I've connected the end line here is the pin out to the ground, which is basically, at the moment the circuit is alimented, the current goes through this side and comes to the ground. So by default, my transistor's base is connected to the ground. Okay, so if let's check the light, the power. Sorry. Let me. All right. I think something is going on. Okay. How to fix this thing? All right. So now the base of the transistor is connected to the ground through this switch here. So normally, if I press it, it should connect the base of the transistor to the high. So when I connect, it goes off. When I disconnect it, when I take it to the ground, it goes on. To high, it goes down, goes off. So, and I think what this is what we call a NOT circuit, which is an inverter, because when you input 0, which is the initial state, it outputs 1, which is high, and when you put low, when you input high, then you have low. So 1 input, 0 output, 0 output, 1 input, 0 input, 1 output. So this how this works. And this resistor usually is called a pull-up resistor, because the way it happens, the way it works here is, whenever the base of the transistor is low, okay, whenever the base is low, I think the current flows from the collector current is also 0 here. No, I think it should actually be high, because the current goes this way, so it goes high. And now whenever we connect the base to the high, then it pulls the current try to flow this way. It's kind of, it drops whatever current is there down to the low, so making this side here 0. So the current here goes 0, because it goes from the base to the collector. No, from the collector to the emitter, the current flows now, and then canceling the current in this small circuit here. So I think this is how it works. Probably I'll get another opportunity to explain this better. So this is a bit a simple not get. The lab is not over today, so let's continue. If anything again, I'll shoot a short video. Thanks, and let me go through the circuit again closer. Right, the power is not stable, so we have it this way. All right, so easy. Is it? So So here it is. So have a wonderful weekend.